CyberthonAI. This is Abhipsit Bajpayee, the leader of Team Canon of Shannon. We have taken the challenge of smart policing, and the challenge is emotion detection of the emergency calls via audio clips. So we have developed a unique approach that combines two models and a master model to extract various features from these audio clips and gives very good results with a very good accuracy of about 99.44 percent. And also we have eliminated the biases of language, the accent, the tone, gender, and most of these. Also, we have targeted the problems like uh, multiple voices in one audio, which can be there in such an emergency call. More details of the problem statement shall be given by my teammate Divyam Goyal. And also in this video only, we have a demo for you in which you can see how a model has been implemented. Also, my teammate Pihu shall explain to you that what has been implemented till now and what shall be implemented afterwards. Handing on to Divyam.
Thank you, Vipsit. So, when we call for help, every second counts, but traditional emergency systems often fall short, relying on words alone to assess the situation. What if the caller is too scared to speak or too traumatized to think? So, smart policing changes that. By analyzing the caller's voice, we can detect the emotional state, fear, panic, or stress. This means that we can respond faster with more precision and save lives. It's not just about hearing words, it's about understanding the person behind the call. So let's make emergency response more human, more passionate, and more effective with smart policing. Thank you. Handing over to you.
Yes. So till now we have deployed the model of our project and with the UI interface, and now we are thinking to integrate like the emergency. We are trying to integrate this model with the calling system and also enabling a feature of location so that we can tap the location of the person as well while he or she is calling.
So afterwards this, we have a demo for you made by me in which I will also explain the model architecture to you. Also, we have a funny video of testing some different songs that have different emotions. Hope you enjoy the demo. Hello everyone, this is a demo of our Neurovox model, which is an emotional detector that uses emergency calls audio to detect the emotion in them. So why is it needed? This is needed for smart policing as it can help us prioritize the emergency calls as per the emotions detected in them, like the calls having emotion of fear or emotion of anger are very important ones. So let's first of all have a demo of it and then we shall know how does that work. क्या लगा रखा है ये? क्या है ये सब? So we can see that we have found a result of disgust. Now I shall try a little bit of acting of crying in fear. Let's try it. Oh, 100% accuracy. So this is one demo of our model. We are still trying to improve it much more. First of all, you can see that there is multilingual support in our model. That is one very good aspect of it. If we see how it works, then we can check it from this about Neurovox. So we use a multi-model architecture approach to detect emotions from audio recordings. First of all, there is a CNN module which processes audio input to extract spatial features like outlines, patterns, and distributions in the waveform or the spectrogram. Actually, we are not converting it into a image spectrogram, but we have used algorithm as such to detect those things also. It captures local acoustic features like timbre, pitch, and frequency patterns. First of all, an audio file can, once recorded, it can be treated as a static file also. Just like a painting has its characteristics, this audio will have some characteristics which this CNN can know. Then an LSTM. Now why? Because it independently analyzes the audio sequence over the time, capturing temporal dependencies and context. It understands how emotions evolve and flow through speech. Finally, a master model. This master models combines the outputs of both CNN and LSTM and gives them the right weightage to produce a more accurate and robust emotion prediction. Now, why this approach? Because spatial and temporal features both are there. We can distribute the learning tasks and avoid any kind of overfitting. Yeah, and it captures fine-grained acoustic patterns and long-term context. And also, we have robustness to noise and speech variation. Now, this is a very important part because most of the time in these emergency calls, we can have a scenario in which noise is there and it can hinder the important part of speech. So, we use an algorithm that uses a FFT, a high pass filter, and then an inverse FFT to remove any noise from the audio. And also, then we split the audio into multiple windows, which, according to a probability, shall have voice of just one person only. Like, even in one audio, we can have multiple persons talking. Let's say a victim and a violence perpetrator. The perpetrator might be in anger while the victim might be in fear. So there are two emotions. How to capture the important one? So these are the things which we are working upon more and more, and we have completed 50% of our code. Also, uh, the accuracy and the F1 score are very good. The accuracy is 0.944 and 0.996 for our CNN and LSTM respectively, and the final master model is also very good. So this was the demo of our model. देखा हजारों दफा आपको, फिर बेकरारी कैसी है। सैड हो गया मॉडल, कुछ और ट्राई किया जाए। छोड़ दिया वो रास्ता जिस रास्ते से तुम थे गुजरे। अरे सैड सॉन्ग समझ आते हैं इसको, कुछ और ट्राई करते हैं। चला जाता हूँ किसी की धुन में। पूरा इमोशन समझता है ये तो मेरा। गानों में कुछ शक्तियाँ हैं।